Welcome back, everybody, to another episode of Math Video. In this episode, we're going to study some key features and ideas that will be very helpful in our unit of study on quadratic relationships. Don't get angry. Oh, I hate these pigs. They're so hard to get, too. They're really kind of like green bullies. So if you don't know how the game Angry Birds works, what you have to do is you have to launch your birds and try and knock over these smug, arrogant little pigs. And once you do, you clear the board to the next level. And when you launch these birds, interestingly enough, they actually take on the shape of a quadratic graph. Yeah, all things that get launched up in the air and have the effect of gravity on them, those are all quadratic relationships. And speaking of quadratic graphs, the graph of a quadratic relationship is actually called a parabola. And a parabola has many interesting features in itself. First of all, they are symmetric, which means they're the same on both sides. They can be split by a line of symmetry. And parabolas can open downward like the one here, or they can actually open upward in a U shape as well. Let's check out some more interesting features of parabolas. Parabolas have x-intercepts, which mean these are the places on the x-axis where the parabola crosses through the x-axis. And parabolas can have two x-intercepts like shown here, or one x-intercept, or no x-intercepts at all. And knowing where these x-intercepts are can help lead us to the next important features, the line of symmetry. The line of symmetry splits the parabola exactly in half, and it's found precisely between these two x-intercept points. And when you know where that line of symmetry is, that's going to lead you to the next important feature on a parabola as well. And that feature is the vertex. The vertex is the maximum point sitting on the top of the parabola, or it's the minimum point sitting at the bottom of the parabola. So to find that vertex, identify where your x-intercepts are, count your way to the middle to the line of symmetry, and then just move up until you find the vertex, either the maximum or the minimum point, and you can find your coordinates right there. And here's another example. Between the two x-intercept points 1 and 5 is 3. There's the line of symmetry. And we track our way down to the minimum point, and there is our vertex at 3, -4. And because a parabola is symmetric, we can also see the symmetry in the table as well. 864 is our vertex, which is found between our two x-intercept points. And moving to or from the x-intercepts up to the vertex, we see that there is repetition. So symmetry can be seen in that data. Here we are going to compare some linear data with some quadratic data to see how they are different. When looking at linear data, we always see that there's going to be a constant increase or decrease. And if we subtract consecutive y numbers, we're always going to see that we get something called first differences, and those first differences are always going to be the same. Those first differences in this example, it's always 3 because the slope is 3, so when we subtract any consecutive y numbers, the first differences remain the same. This is not the case with quadratic data. When subtracting consecutive numbers of quadratic data, you can see that the first differences are definitely not the same. However, there's a very interesting pattern going on here. Going up 1, then going up 3, then going up 5, then going up 7, then going up 9. It's always going up by that next odd number in this case. So there's always some kind of increasing pattern within quadratic data. And what that does, that produces some second differences that will be the same. All the second differences here are identical. So linear data, your first differences will always be the same amount due to a slope. And in quadratic data, it's your second differences that will always be the same. Whoa, baby, look at this board. Alright, evil pig, you're in my sights. You're on target. Prepare to meet your demise. Okay, so let's overlay a grid on top of this and see what type of quadratic equation will help me get over this huge obstacle. So my x-intercepts here are 0, 0, and 8, 0. And I'm going to need to get up to a maximum point at my vertex here at 4, 16. Alright, I think these equations here, either one will give me the correct parabola path to destroy that pig. So both of these equations are equivalent. They're just in different forms. The first one is considered expanded or standard form, and the second one is considered the factored form. So you know you're looking at a quadratic equation when you see that you have a variable to the power 2. No higher power than that, exactly to the power 2. Or if you see that you will have a variable times a variable, times the same variable, which will also make to the power 2. That can be your little indicator. So the way that I remember the difference between expanded form and factored form is that the expanded form has the exponent. The factored form has little parentheses acting as fences. Fences start with F, and so does factored. Oftentimes, the factored form is a more usable quadratic form. It better allows you to find your x-intercept points, which then allows you to find where your line of symmetry is, which then will lead you to your vertex. Let's see how that works in this example. It's important to remember that x-intercepts are always sitting on the x-axis, which makes their y-coordinate exactly 0. So with that being said, that means that the x numbers that make the equation, or the y, equal to 0, well, that means those would be the locations of the x-intercepts. So one way to make the y equal 0 is if we use 0 in the place of x. 0 times anything is going to equal 0. So that kind of corresponds with this x-intercept right here. When we use 0, we get 0. The other way to make y equal 0 is if we use 8 for the x. 8 take away itself is going to be 0, so 0 times anything is also going to be 0. So when we use 8, we get 0 for our y. We have just found the two x-intercepts and proved it with our equation and our graph. So again, once we know where our x-intercept points are, at 0 and 8, we know exactly in between 0 and 8 will be 4, which is where the line of symmetry is. And if we slot in that x number into our equation, we can see that we are going to develop where that maximum point is. 8 minus 4 is 4, and 4 times 4 is 16. So knowing the x-intercepts led me to the line of symmetry, which then gave me the x number to plug in to get my maximum point. Alright, pig, prepare to meet your demise. Here is another parabola where the x-intercepts are 0, 0, and 20, 0. Line of symmetry would be at x equals 10, and therefore our maximum point would be at 10, 10. So the equations that would create this parabola path would either be this expanded form. The expanded has the exponent, expanded exponent, and this would have the factored form. Parentheses acting like fences, factored has an F, just like fences. Birds away. Hopefully now you have a better understanding of quadratic relationships and the parabola graphs that they make. Take a minute to review the topics that we've discussed, and have a great day.